All right, welcome back. Let's go back to our workflow. And you should have this diagram here if you want to reference it at any point. You can also, if you have never used this, it's called Split Editor. Close all this stuff that I don't need. It's a split editor, so you can do a side-by-side view of things like ERDs if you've built them right here. And let's go ahead and use that for this part. Let's scroll down. So step number 3 is we're actually building these tables. So first things first, we have created a SQLite 3 connection. We named it conn, C-O-N-N, and that's just SQLite 3.connect. And then we are storing it inside the data folder, right? And actually that is not going to work. You are going to need to change that to /data because we're inside a notebooks folder. So we need to move into the parent directory first, which is just the main project directory. And then we can go into data and superstore.db. It does already exist. It ended up getting pushed to the repo, but if it didn't, it would create a new one for you. And if it does exist, then it just tells SQLite, hey, use this database. This is what we're using. First, let's create some data frames. So using this schema, we'll make separate data frames for each table that we want in our database. And as you'll see, all of these fields, these are just column names. So we can filter our original data frame based on the column names that we want. Okay, so we've got customer ID, customer name, customer category, city, state, region, and it looks like we actually missed postal code here. So let's add that in. Postal code. Okay. It's important to drop the duplicates because you just want one of each. Because right now, of course, in this big CSV file, there's a ton of redundancy. These things are going to repeat over and over and over. You don't want any duplicates of these things. You only want one row for one customer ID. Well, then I chose to use this .rename columns in place here. Okay, and it's just a dictionary that tells what we want. And let's go ahead and change postal code to postal code. You don't actually have to do this. Again, this is personal preference for me. I like it this way. If you don't want to do it this way, you don't have to, although this is already typed out, so it might be easier just to leave. All right, now we can look at our products as the next one listed. So product ID, name, category, and subcategory. We've got all of those in here. These are just our columns. So it's saying, hey, take this original data frame, only include these columns, drop all of the duplicates, so we only have the unique values for these. And then we're going to rename the columns the way that we like. We do the same thing for orders and order details. Now, these data frames are all created. This is what they're called. For each one of these, you can create a table by using the .to SQL. So you have the data frame name, .to SQL. You give the table a name. This is the name of the table. You tell it the connection. We named ours conn at the top here, see? It does not have an index. We'll say index equals false. And if it exists, replace it. That's simply saying like, hey, maybe you've run this code before, you're trying to test out something new. If that table exists, it's fine. Don't throw an error, just replace it. When we're done making all of these changes, we will commit them. Let's try running this. And everything looks good. We'd like to look at it though. So if you remember, I'm going to actually close out here. Go to this bar at the very top, see up here, click on that, show and run commands, SQLite open database. We'll choose the Superstore database. Now our SQLite Explorer pops up. Make it a little bigger here. We can open it up and ta-da, all of our tables are here. Customers, order details, orders, and products. So you have successfully taken this giant flat file that's crazy, it would be really hard to do a lot of queries through this because there's so much repeating data. It makes it a lot more complicated. But now you have this beautifully designed relational database that is very simple. After this, we're just going to make some queries. The pattern that I have set up for you here is you'll just write your code inside these strings where it's saved as the query. And that's all you have to do is just write the query itself. And then this part, don't change this part. Just leave it alone. It's just saying, hey, the first result, we're going to do pd.readSQL, which is that really great pandas command that allows us to execute SQL queries. We tell it which query to use, which is this first one, and tell it which connection to use, which is that same con that we have. And you'll notice that's why we have this con.commit. We did not do close. We did not close it out. It's still open. We're still working with it. We'll do this little sample one. We'll run it. This question says, which customer segments bring in the most revenue and profit? That is a very reasonable and important question that someone might want to answer. We can run this and see. All right, well, this is total sales ordered by total sales consumers, consumer, corporate, and home office. That's really good to know. And as you can see, this would be a very easy table to use for a visualization. If you wanted to make a bar chart, for example, to compare sales and profit for these three categories, think of how simple it would be if you're just using this. Now I'd like for you guys to go through and answer the rest of these queries on your own. So you have things like, what are the top 10 customers by total sales? Which product categories and subcategories are the most profitable overall? What is the average discount given per category? Which states or regions contribute the most to total sales? You can just choose one of these. You don't have to, like you can choose by state or region. You don't have to do like both in the same one. How many orders were shipped late? What month or year had the highest total sales? What are the most frequently ordered products? Which customers placed more than 5 orders total? And what's the profit margin by category or segment? So choose one. Category, or actually segment, we ended up changing that. Category, or we'll change that to customer type. This won't change on yours, but that's okay. You're watching the video, so you'll know. All right, so you'll go through all of these, and these are really great questions. You can imagine this in a business setting. These are very reasonable things like, hey, we want to know each category of sales, like what's the profit margin? You can do that using SQL. Next, I'd like for you to make some visuals. So from these 10 results, you'll have 10 different results here, which are each just a nice little data frame that you can use for a visualization. I'd like you to select at least 4 to utilize in a meaningful visualization. Try to do at least 4. Try to do some different types if you can. Don't do the same visualization every time, but do something that makes sense. So here's an example. We'll run this in, and this one, it used the result 1. So remember how I mentioned, oh, this would be a good thing to maybe do a bar chart with? You can read through this to look at it, but that's what we did. We used just that little table to say, hey, here are the total sales. Here's these different categories. And look at that, home office has substantially less than consumer. That's interesting. One thing I do want to point out is you guys see how this looks over here? It's dollar signs, it has the full number. That was not the default with this type of graph. It was in scientific notation, and that is where we used mticker, right here. So we got the axes objects, right? And then we're looking at the y-axis. It says set major formatter, and then you can do this mticker function formatter, and it uses a lambda, and it's pretty much just saying, hey, put a dollar sign in front of it, have it the number itself, but do it with as a full number with 0 decimal places as a float. It's telling it don't format this in scientific notation, make it just a regular float, put a dollar sign in front of it, but put commas in between. And again, that's not something you need to memorize. That's something you can find, you can Google that, and you can look up in the documentation or look in your notes. tricky things that look kind of like that. They're sometimes hard to remember, but they're really useful. And once you use them once or twice, you know, it'll start to come back to you a little bit more quickly. But you'll have some spaces here. So in these code blocks, write in at least 4. Do as many as you want. As many as you want. I'd also love for you, if you want, you can make another markdown cell at the bottom. And I'd love for you to write any feedback or questions that you have. This is the last major tutorial for this module, and I'd love to hear any of your feedback, good or bad. Criticisms are highly valued, compliments are fine too, but honestly, if you have anything that you would just really like to express about this exercise or other exercises, if you put it at the bottom of this notebook here, it's a great way for me to be able to read it, and then I'll be able to incorporate it, you know, into any lesson changes, and then also I can reach back out to you directly if needed. And that's that. Thank you guys so much. I hope you enjoy this tutorial. Be sure to save everything, add, commit, and push to GitHub, and then add your repository link at the bottom of this lesson right here.